You're looking live at Launch Pad 39A and the SpaceX hangar just there to the lower right, where inside there's a horizontal SpaceX Falcon Heavy rocket with NOAA's GOES-U weather satellite attached. Currently, rollout is scheduled for this afternoon, and we are set for a T0 tomorrow at 5:16 p.m. Eastern Time. Now, just a few days ago, back up just a little bit, NOAA's GOES-U weather satellite was encapsulated in a fairing to protect it from the elements as it awaits launch. And there you see it there, all folded up. But also on launch day, that fairing will help protect it when it flies through the atmosphere on its way to space aboard a SpaceX Falcon Heavy rocket. By the way, GOES-U is the first NOAA satellite to fly on a Falcon Heavy. Hello and welcome to the Kennedy Space Center in Florida for NASA and NOAA's briefing on the science behind GOES-U. My name is Daryl Nail, and I'll be the moderator for today. And we have assembled a panel of experts for you to answer your questions, as well as talk about the mission of GOES-U. They're going to discuss how the satellite benefits you, the public, as well as how it does that job. We'll also discuss a new instrument on board GOES-U, in addition to the next generation of weather satellites that will follow this current series. GOES stands for Geostationary Operational Environmental Satellite, and the U is the letter designation for the fourth and final satellite in this current generation of GOES satellites that began with the letter R. The next generation is called GeoXO, and we have a lot of great information that we'll be sharing with you in just a few minutes. Again, I mentioned the T0 is 5:16 p.m. Eastern Time. So with that, let's now, tomorrow, June 25th, let's now introduce our panel. And starting with Dr. Dan Lindsey to my left. He is the Chief Scientist of NOAA's GOES-R program. We have Ken Graham, Director of NOAA's National Weather Service. Also here, Dr. Elsayed Talaat, Director of NOAA's Office of Space Weather Observations. And we have Dr. Charles Webb. He's the Deputy Director of NASA's Joint Agency Satellite Division. And Lieutenant Commander Chris Wood, a NOAA Hurricane Hunter pilot. Now, we're joined in the room and on the phone by members of the media as well, and we're going to get to those questions. But we'll also be taking questions from online. So if you have social media, you can submit your question with the hashtag AskNASA, and we'll call through those questions and get to as many as we can. But we want to begin with some opening statements, and we'll start with you, Dan.
Thank you very much. Good morning, everybody. GOES-U will be the fourth and final satellite in the GOES-R series. We started with GOES-R back in 2016, which became GOES-16, followed by GOES-S&T, and then tomorrow we'll be launching GOES-U. Following reaching geostationary orbit, the satellites are renamed from letters to numbers. And so, as I mentioned, GOES-R became GOES-16, etc. And so GOES-U will become GOES-19. It will initially be placed at 89.5 west longitude over the equator for checkout. That's roughly over the center of the continental U.S. It goes through a checkout of a number of months, and assuming everything looks good, it will be moved over to the GOES-East position, which is at 75 west longitude, sometime early next year, where it will replace GOES-East, which is currently GOES-16, as the operational GOES-East satellite. In the GOES-East position, it's able to see the Atlantic Ocean, the Central and South America, North America, in order to look for things like hurricanes, severe storms, wildfires, and all sorts of hazards that occur in that area. The satellite has the same complement of instruments as the first set of satellites, R, S, and T, 16, 17, and 18, with one addition, something called the compact coronagraph. The primary two Earth-pointing instruments are the Advanced Baseline Imager, or ABI, and the Geostationary Lightning Mapper, or GLM. Those two I will focus on today, and Dr. Talaat in just a few minutes will be discussing the space weather instruments. If you could go ahead and run the video. I'm going to talk briefly about a few of the key applications of the GOES satellites. From its GOES-East position, GOES-U, becoming GOES-19, will be the sentinel in the sky to keep an eye on hurricanes. This example that you're looking at here was from way back in 2017. It shows Hurricane Maria as it approaches the island of Puerto Rico. We're able to scan these big storms as frequently as every 30 seconds in order to get minute-to-minute warnings out to the public. In this particular example, unfortunately, Hurricane Maria made direct landfall on the eastern part of Puerto Rico, doing significant damage, knocking out the radar there. And forecasters actually used the satellite imagery itself to aid in issuing things like flash flood warnings or, severe storm alerts to the folks on Puerto Rico since we lost the radar. Another key addition to the GOES-R series that we didn't have prior is the GLM, or the Geostationary Lightning Mapper. In this example here, you can see the flashes of lightning occurring within the eye wall of this hurricane. Research is underway now to better understand how to make use of that data. What does it mean when we have lightning in the eye wall? Does it mean the storm is strengthening, weakening, or sort of remaining the same? The second key application I want to mention is for severe storms. In the GOES-East position, GOES-U will be the primary satellite for looking at the center part of the country, places like Tornado Alley, or really severe storms throughout any of the continental U.S. One of the major threats in the Central Plains is something called a supercell, and that's the examples that you're looking at here. We can see the lightning from those supercells and get that lightning warning out to the public. Forecasters use the minute-by-minute data, like the visible imagery you're seeing here, by zooming in on individual cumulus clouds, and they're able to then tell when and where those initial thunderstorms are going to form and warn the public as a result of that. One new really cool application that's been developed based on lightning is called Lightning Cast. This was developed by our friends at the University of Wisconsin. It's a machine learning algorithm that predicts the probability that lightning will occur within the next 60 minutes. The way this is used is, for example, say that there's an outdoor sporting event. Forecasters can look and see the probability that lightning will occur in the next hour, and if it's a high probability, they may consider warning the public, getting the people who are on the field to safety, and getting the fans to safety. Another application is volcanic eruptions. The example you were looking at in just a second ago was from the Tonga eruption. It's really important to keep the airplanes away from those volcanic ash clouds because they can damage the engines. And then the final application I'll mention is fire detection. This was perhaps the biggest surprise with the GOES-R series on how well we can do fire detection. The near-infrared channels of the ABI are able to detect the hot spots from those fires. We can track the hot spots as they progress out from the fire, and we can get that information out to the emergency managers, out to the firefighters, in order to keep everyone safe. In addition to the fires themselves, we can see smoke from the fires, and this is important because smoke causes significantly reduced visibility. It can actually cause air quality problems, human health problems, and it can also be a threat to the firefighters themselves who are trying to fight the fires. Following the GOES-R series, the current plans are to implement a new program known as Geostationary Extended Observations, or GeoXO. The first GeoXO satellite will launch in 2032, and there's going to be some key improvements to a number of applications and some new observations as well. In terms of fires, we're going to improve the spatial resolution of the fire detection channel by a factor of 4. And what that means is we'll be able to detect hot spots that are 4 times smaller now. In the future, we'll be able to do it 4 times earlier, basically, and see those fires before they see the fires before they spread too widely, and get the emergency managers out, get the firefighters there to put the fires out. And with that, I'll pass it on to Ken.
Dan, absolutely amazing to see the satellite and some of the usages. I'm Ken Graham, Director of the National Weather Service, and our forecasters across the country using this data to put out forecasts and warnings. The GOES-R series of satellites it's been a game changer for us. It's been a game changer for our forecasters. Since the first launch of the series in 2016, the latest generation of GOES has enabled new and improved forecasts, warnings, services to help save lives and protect property, while our meteorologists rely on other observations like the radar and buoys, for example. The GOES series of satellites consistently provides imagery of weather features in the Western Hemisphere for us. The GOES-R series creates a full disk of the Earth every 10 minutes. So our Weather Service meteorologists often request enhanced scanning of rapidly evolving storms, as Dan was showing in the imagery, and other phenomena as well, like hurricanes and volcanic ash and fires, and we can get imagery as up to 30 seconds, which is absolutely useful for our warning capability. So we're going to start the first video and look at some recent events using the satellite. And this first one, the GOES Advanced Baseline Imager, the ABI, allows meteorologists to see rapidly developing convection. This video shows a derecho, a powerful storm stretching hundreds of miles, producing wind, hail, lightning damage along its entire path. In this case, around Houston, winds toppled 100 miles an hour, and just incredible amount of damage on May 16th. But observations from the GOES East enabled our meteorologists to really look at issuing those severe thunderstorm warnings, those tornado warnings, so residents along the derecho's path have the information that they need, even during the nighttime hours when these things are most dangerous. Meteorologists are able to use the GOES information to be able to look at the lightning mapper, the GLM, as a leading indicator of the storm severity. Our next image, look at this next loop here. Weather Service forecasters provide proactive and tactical wildfire decision support services using GOES. The 16 channels of that Advanced Baseline Imager, or ABI, on GOES East detect the difference between cloud droplets and smoke particles. This technology became crucial in June of 2023 when the northeastern United States experienced unprecedented concentrations of smoke from wildfires blazing in Canada. The next one is interesting as well. The next loop shows fog, our ability to pinpoint when fog will develop and dissipate, significantly improved by GOES satellites. This video shows how the ABI can differentiate between thick fog in the nation's heartland and weather-making clouds above. That level of detail is incredibly beneficial to aviation forecasters and navigation along rivers and highways and transportation, and keeping everybody safe and reducing delays. Now let's talk about space weather. Dan mentioned some of the space weather aspects of the satellite. The space weather forecasting is a big part of the National Weather Service's mission. Our forecasters at NOAA's Space Weather Prediction Center rely on observations of the sun's atmosphere to analyze data, helping them predict the timing and protect assets as well, and the strength of those geomagnetic storms to issue alerts and warnings. If we start the video, it really shows some of the space weather in action. We are currently at solar maximum. So this is an important time to be having this type of data, the peak of a roughly 11-year solar cycle. In early May, several coronal mass ejections, CMEs, produced a G5 storm, the highest category on NOAA's space weather scales, resulting in really a big event on May 10th and 11th. It was the strongest geomagnetic storm in 2 decades, very powerful. You may have seen the impressive auroral displays. With GOES-U, we're getting an important instrument to help the space weather forecasting, the compact coronagraph for SEACOR, the first operational SEACOR, and we're incredibly excited to see this sensor to really impact our early warnings. This new instrument will deliver imagery of the sun's corona to our forecasters at the Space Weather Prediction Center within 30 minutes, and that's compared to the previous time. It used to take about 8 hours, so that's an incredible advance in us having that capability to have that data. The instrument will really capture multiple images of each flare and CME, improving our understanding of their size, velocity, and also the intensity. Geomagnetic storms can impact our infrastructure here on Earth, putting our power grid, communications, navigation systems, aviation, space-based assets at risk. Having a better and faster observation will help us better alert our infrastructure providers and potential hazards so they can take action. Thanks again for this incredible opportunity to be here and talk about the importance of GOES to the National Weather Service. I'm thrilled to be here for the GOES-U's launch and eager to get the GOES data in the hands of our dedicated meteorologists that work 24 hours a day to keep everyone safe. So with that in mind, I'm going to give the floor over to my colleague, Elsayed.
Thank you, Ken.
Yep.
And good morning, everybody. This past year, we had the remarkable opportunity to witness not one, but several cosmic masterpieces throughout the nation. The first being the Great American Solar Eclipse. Let's roll the first video. And more recently, the Aurora Borealis, known as the Northern Lights. This visual manifestation of space weather was seen in all 50 states for the first time in 20 years. Each of these celestial wonders gives us insight into our sun and its activity called space weather. For decades, NOAA has observed space weather to produce the warnings, alerts, and forecasts that Ken just mentioned. This allows industries such as the power grid to take proactive measures to mitigate against potential disruptions. This also includes our communication systems, which are essential for emergency response efforts during national disasters, such as hurricanes and tornadoes, and for pilots to safely fly our planes with functioning navigation and communications. Furthermore, as space commerce and space exploration grows, so too does our need for observation and forecasts to protect our assets in space and astronauts. We are thrilled to be here today and excited for the launch of the GOES-U satellite for several reasons. One, being that it will carry the nation's first operational coronagraph called SEACOR-1. Next video. This means that for the first time, we will have continuous observations of the sun's fainter outer atmosphere, creating the equivalent of a total solar eclipse every 30 minutes. In doing so, this powerful solar telescope will allow us to observe the corona, which is the region where extreme space weather events originate. The coronagraph, working in tandem with the magnetometers, solar ultraviolet imagers, and extreme ultraviolet and X-ray irradiance sensors aboard GOES-U and GOES-18, operating in the GOES West position, will strengthen NOAA's ability to predict space weather. Because we are looking at the sun in the ultraviolet and X-ray frequencies, which we can't see from the ground, having such instruments in space allows us to see it 24/7. We also need to make measurements of coronal mass ejections in space to get an unobstructed view of the large explosions off the sun. This next video that you see, taken from the LASCO coronagraph and the GOES solar ultraviolet imager, is an example of what SEACOR-1 and the SUVI instrument on GOES-U will capture. They will see and sense the solar wind, solar flares, and coronal mass ejections that can send billions of tons of highly magnetized material hurtling towards Earth at several million miles an hour. In addition, images will come back to us much cleaner and of higher resolution because the space weather instruments on GOES-U were built to be more resilient and to better withstand the impacts that can create the white specks or snow on detectors that you see here during extreme space weather events. These data will serve as the primary source for information about impending geomagnetic storm conditions, allowing NOAA's Space Weather Prediction Center to issue warnings and watches 1 to 4 days in advance. Once operational, SEACOR-1 will mark a new chapter in space weather observations. It would also signify the beginning of continuity of observations, which is needed since many current platforms, including Discover, SOHO, and ACE, are aging and either near or beyond the predicted end of life. As part of NOAA's Space Weather Follow-On, or SWIFO, program, SEACOR-1 is the first in a series of coronagraphs that will be positioned in various vantage points. Next video. Next year, we will have a coronagraph on the SWIFO observatory at Lagrange Point 1, roughly 1 million miles from Earth between the Earth and the Sun. It's pictured here. At a third coronagraph, part of NOAA's Space Weather Next program, will be on the European Space Agency Vigil mission, taking measurements 100 million miles away from Earth to give us a stereoscopic view of the Sun. It is vital that we be vigilant in our space weather observations to protect our economy, national security, and individual safety, both here on Earth and in space. Although the Sun is no more active than in previous generations, our society has changed, and we are more sensitive than ever to the Sun's changing mood. Next video, please. NOAA satellites are the backbone of our country's plan to become a space weather-ready nation, and we look forward to this historical GOES-U launch, getting us closer to the types of measurement we need on a continuous basis to be responsive and resilient to space weather events. So now I'll hand it off to Charles, and thank you, and go GOES-U.
Thanks, Elsayed. As Darrell mentioned, my name is Charles Webb. I'm the Deputy Director for the NASA's Joint Agency Satellite Division. Our division is part of the Science Mission Directorate at NASA, and on behalf of NOAA, we manage the development and the deployment of operational weather satellites like GOES-U. The GOES series of satellites extends back to 1975 with GOES-1 and are the cornerstone of weather observing and forecasting for the Earth's Western Hemisphere. While sensors on the ground, as we all know, like radar, directly measure local weather conditions, meteorologists also need to make measurements high above the Earth's atmosphere to observe the big picture remotely. and data from satellites like GOES-U enable forecasters to issue accurate, timely, and reliable watches and warnings to the public. As Dan mentioned, GOES-U is the fourth and the last in the GOES-R series, having been preceded by GOES-R, S, and T, which are now GOES 16, 17, and 18. And once launched, GOES-U will become GOES 19. This series, the GOES-R series, is the nation's most advanced fleet of geostationary weather satellites, improving hurricane tracking and intensity forecasts, increasing the lead times for thunderstorm and tornado warnings, and improving aviation flight route planning, and providing data for long-term climate variability studies. NASA is responsible for the formulation, the development, the launch, and initial operations of the GOES-R satellites before we transition long-term operations to our colleagues at the NOAA Satellite Operations Facility in Suitland, Maryland. GOES-U will provide advanced imagery and atmospheric measurements of Earth's weather, oceans, and environment, real-time mapping of total lightning activity, and improved monitoring of solar activity and space weather. Our team has incorporated many of the lessons learned during the development and operation of the previous 3 satellites in the GOES-R series. And in addition, NASA has also solicited research through the Earth Science Division to develop land, ocean, and atmospheric data products from geostationary weather satellites, including the GOES-R series. Applying research algorithms that were originally developed for low Earth polar orbiting instruments to geostationary weather data produces data products that are with similar spectral resolution, but with greater spatial coverage and higher temporal resolution. And as a result, these data products support long-term trend analyses, which look for slowly varying processes within the Earth system, as well as short-term investigations that look for fast-changing phenomena, thus closing the loop from operations back to research. Our 5-decade partnership with NOAA has resulted in the successful operation of more than 60 satellites dedicated to weather forecasting, severe storm and hurricane prediction, and climate observations. We are also proud to continue this partnership into the future as we move further into the design phase of GeoXO, the system of geostationary satellites that we will deploy in the 2030s. But today, our focus is obviously on GOES-U. The NASA NOAA team has been working diligently with our industry partners to be fully ready for our launch opportunity tomorrow. We're very proud of how NASA and NOAA have collaborated over the life of the GOES-R program, and we look forward to getting GOES-U into orbit and on station as GOES East. And with that, I'm going to turn it over to Chris.
Thank you, Charles. I'm Lieutenant Commander Christopher Wood. I'm a Hurricane Hunter pilot with NOAA's Aircraft Operations Center piloting the WP-3D Orion. Advanced environmental modeling for weather prediction requires a coordinated observation system of both in situ and satellite information. NOAA delivers a suite of information for tropical cyclone prediction and forecasting, including surface observation, coastal tidal information, weather radar, aircraft reconnaissance, and of course, satellite data. NOAA observations from satellites and aircraft in the storm environment are necessary to best understand the rapidly evolving conditions within these cyclones so that we can give that information so that emergency managers and anyone impacted can make their best decisions for the protection of their lives and property. Additionally, equipment on NOAA aircraft supports satellite testing, validation, and calibration, such as with ocean surface winds. The more that we can observe and understand conditions in these boundary layers of tropical cyclones provides us the best information for forecasting storm changes, such as the potential for rapid intensification. NOAA Hurricane Hunters use the GOES satellite information as part of our pre-flight planning so that we can get the best information prior to heading out into these storm environments. This is particularly valuable when we don't have an aircraft in there providing real-time information. I'd like to end briefly with a quick video taking everybody through an eyewall pass as we go into Hurricane Laura. So this is part of the Hurricane Pass itself. We fly these with at least 2 pilots at the controls at all times to maintain the aircraft in a safe attitude, as well as a flight engineer who is monitoring our engines to keep us within a very narrow speed band so that we can safely penetrate the storm environment. Additionally, not seen here, will be one of our flight directors. The flight directors are in-flight meteorologists, and they're giving us slight corrections to safely avoid the worst that these storms have to offer while still collecting the data that we need to collect to get to all of our partners. And here shortly, we're going to come through the end of the eye wall, and you're going to see it open up into the eye into a nice stadium effect. When these happen, it's really a beautiful sight to hold. And here we go. So they just got through, and you can see just that stadium effect with the clouds just making a nice big wall there. It's uncommon for this to happen, but when it does, it's definitely a really nice end to that pass before we go through on the other side on our way out.
All right, thank you very much, and impressive video there. All right, we're going to take questions now, so if you have a question in the room, please raise your hand. We're also going to take questions on the phone and on social media, and we'll start with a question on the phone and go to, let's see, Mike Linden from MyRadar.
The way that people can view the weather around them as images and animations are shared on social media. So as mentioned previously, it's been a huge year for space weather, where we saw a huge impact of the images from the northern lights and the geomagnetic storm all over social media. With the advancements in the CCOR1, what kind of impact do you expect that having on social media once people can access the new imagery?
I think this is to me. So with the CCOR imagery that we're going to be able to get, that's as Ken said, is going to be a game changer for space weather observations, in the sense that we'll be able to see these explosions off the sun within 30 minutes of taking the pictures. It's in the hands of the forecasters and also in the hands of the public, so they can see these the incoming, possibly incoming solar events. So in terms of how it's going to impact social media, I hope that it will raise awareness of these space weather events when we have the incredible imagery that we're anticipating getting from the GOES-U satellite.
All right, thank you very much. And now let's take a few questions from social media. We have a user on X named Juka, and this person is asking, what orbit will Falcon Heavy deliver it to? So the orbit, anybody familiar? We know that it's going to a geostationary orbit. Initially, though, it's a geotransfer orbit, and then it raises itself.
Correct. So the launch vehicle itself has enough power to deliver the 11,000-pound fueled spacecraft to a geosynchronous transfer orbit, and that's a very elliptical orbit. It goes all the way out to the geostationary altitude of 22,236 miles above the Earth. But the other side of it, the perigee, the closest point to the Earth, is only a few thousand miles above the Earth. And what happens is once the spacecraft separates and goes, its own fuel system will essentially raise up the other side of the orbit to that circular geostationary orbit, and then it will be moved slowly from the longitude that Dan mentioned that it would be dropped off at 89.5 all the way back over to 75 degrees west. And so that will take a number of weeks to get on station there.
All right, thank you very much. And our next question comes from X-user Phil Moyer. And he asks, I've worked on thermal imaging satellite design for wildfire early warning. How small of a fire can GOES-R detect? Smaller equal earlier warning. And how does that compare to terrestrial detection? Will GOES-XO have more advanced capability? So let's take that first part of the question about how small of a fire can it detect?
Yeah, that's a great question, and it's a question we get often. And the answer is it really depends on several things, including how hot the fire is. So the hotter fires, generally you can see them when they're smaller. An example that I like to bring up is one of our Weather Service colleagues a few years ago over the middle of the night detected a hot spot by looking at the imagery from the ABI. and called up the local folks. I think this was in Kentucky, and they sent somebody out to take a look, and it turns out there was a barn on fire. So this is something as small as a barn. It was really hot, of course, in order to detect it. And to get to the second part of the question, for GeoXO, since we're improving the resolution of that fire detection band by a factor of 4, in theory, that means something 4 times smaller we would be able to detect at the same time. So perhaps a large barn now and maybe a small barn then, or if we can detect 1 acre now, a 1 acre fire now, we could detect, say, a 1/4 acre in the future. So it's really something to be excited about.
And how quickly can you get that information to emergency responders?
Within minutes, and that's one of the advantages of being able to scan so quickly. We can scan as quickly as every 30 seconds, and then as soon as the scan is done, that information is sent out, and within the next, say, minute after that, so almost immediately.
Mm-hmm. So we're taking questions from social media right now. So if you have one, just hit us up with the hashtag AskNASA. In the meantime, I'm curious about something that you showed us, Ken, and that was that derecho going over Houston just recently happened. You mentioned that there's also some predictions, some machine learning that you're using to predict lightning levels. How does that work? Is that associated with AI?
Yeah, there's different research going on about the lightning, and you have incredible about a building lightning. It really talks about a strengthening storm and really building up that storm and looking at the warnings. There's some research that talks about dropouts in that lightning could be indicative of tornado genesis, the start of a tornado. So that kind of research, you think about the operational nature of the GOES satellite, but there's also the research component that every time you get a new piece of data, you see things that's like that you haven't before. And you learn from that, and you put that into the research to operations, and that really feeds new operations, which is absolutely incredible to be able to do that. So the derecho was one of them, and even more recently, we had some storms in Texas that sent out an incredible amount of dust on an outflow boundary into New Mexico, and we were able to put out warnings even recently based on what we saw from GOES. So you think about how that impacts operations. The quicker we can see that, the quicker we can get the data, the quicker we get the warnings out, and it saves lives in the end.
An incredible 100-mile-per-hour winds on a derecho. That's amazing. Yeah. And you have the imagery that matched it, and that's very powerful indeed.
Yeah, and it's interesting to think about. We have the radar observations that we have, but we don't have radars everywhere. So you think about some of the gaps in those observations in the western United States. We can fill some of those in with the satellite data.
All right, very good. We have another social question, and it comes from Eliv. She asks, will a GOES-R mesosector be focused onto the launch tomorrow? I think it would be awesome to use GOES-R to watch the launch of its replacement.
So I can take that one. The answer is probably yes. It does depend on whether there's other things happening in the U.S. that are higher priority. Perhaps, I don't know what the forecast is, but if there's, say, severe storms in somewhere else in the country and something else happening somewhere else, that may take the mesos away. But very likely we will have a meso. And what that really means, for those that don't know the term meso, is it means doing these 1-minute scans. And so when you scan Florida, say, every 1 minute, that's able to sort of resolve or capture the hot spot from that rocket launch as it moves away. And so look for that. We really hope to have the meso in place there.
And it did capture the launch of Artemis 1 back in November of 2022. That clip is online. We have that clip as well. We'll be playing that on our launch broadcast. But you literally can see, that's a big rocket, right? The Artemis rocket, the SLS, and the Orion spacecraft. And it punches a hole in the cloud layer that was over top of the Kennedy Space Center at the time, and then flies right through it. Yeah. It's a cool image to see, so check that out. We'll have it on the launch broadcast, which will be tomorrow at 4:15 p.m. Eastern. A little plug there. Let's go to the phone lines now and get a question from Ken Kramer with Space Up Close. Go ahead, Ken.
Hey, thank you for doing this. Yeah, I got a question for the second speaker. You mentioned that you can distinguish fog from clouds. I wonder if you could talk about that a little bit more, and what does that tell you? How do you do that? And also talk about the lifetime of these 4 satellites, please. Thanks.
Yeah, it's an incredible tool to be able to see the fog. And the event that we showed on the video, it was just a huge event throughout the whole Midwest. It was just a large fog event that we're able to see. So you can detect it. There's technology, and also the forecaster on the desk can look at the clouds that are moving, but there's another sector of clouds that are a little bit darker shade that aren't moving. And it's like, wait a minute, what is that? And you start to really do the analysis with the observations on the ground, and you can see that it's fog. And there's big impacts. You think about the large traffic accidents and pileups that we've had. So if giving the heads up to the local officials to be able to possibly close roads or actually put the highway signs and start talking about some of the fog. But it's also navigation. You think about navigation delays, the Mississippi River, the big ports across the country, and has big economic type of impact as well. I will say something else that we didn't mention. In the wintertime, if you see some of the bright spots that don't move, snowfall. So you can actually see where the snow has fallen in areas, and especially in the south, you can see some of the swaths associated with that, and it's pretty amazing to be able to look at that. So I'll turn it over to others to talk about the lifetime of the satellites, which is about 10 years, if I remember right, but we'll get some more detail on that.
Yeah, Ken, that's correct. The design lifetime of the satellite is 10 years, but they also are designed to withstand 5 years of on-orbit storage. And so the total design, the operational lifetime is the 10 years. However, many of the GOES satellites have exceeded their lifetimes, and two of them, for instance, GOES 13 and GOES 15, were actually transferred to the Space Force, and they have operated them, or they recently, they operated GOES 13 for a while over the Indian Ocean, and then we recently transferred the GOES 15 satellite to be a replacement for that satellite over the Indian Ocean as well. The longest serving GOES-U actually lasted for 40 years, admittedly not doing all of the things that it had been designed to do, but serving as a communication relay essentially for scientists that were in Antarctica. And so as the inclination of the orbit changed, it became visible from Antarctica and served as that important communication relay for those folks in that very remote region. So the satellites are designed to last a long time because this is an incredibly important capability for the nation. But that's the technical answer.
All right, very good. Thank you, Charles. And we're taking questions live right now. So as you punch them in, we're putting them out to the panel. And we've got another one here from Noah Cote, who is asking, what will happen with the current GOES East? Could it be moved and used for a new position over the central U.S. to cut down on the parallax effect with satellite imagery?
Yeah, great question. So what's going to happen with GOES 16, which is the current GOES East, is after it's replaced by GOES 19, it will be moved to 105 degrees west longitude, which if you don't have your longitudes memorized, that's roughly about the longitude of Colorado and over the equator. And from that position, it will be the standby satellite or the backup satellite. And what that means is if there's a problem with either GOES East or West, if something happens, it goes down, then we can turn on the GOES 16 and basically replace it. And it's sort of a backup capability. We don't operate it from that center position because currently NOAA really only has 2 operational slots in the GOES East and West. It can be tested from that position, but it's mainly there as an emergency backup.
All right, thank you. And now a question from Adriano Ferreira, who asks, in regards to the space weather observations, how would this information be controlled or shared outside the USA, Dr. Talaat?
Yes, all the data from our space weather instruments and from the GOES-U are free and open to the public outside the U.S. or for research in retrospective at the National Centers for Environmental Information. Retrospective data is available at the National Centers for Environmental Information. So all NOAA data is free and open.
And I have a follow-up question to that, Dr. Talaat. You mentioned and showed this new coronagraph that's going up on GOES-U. The imagery that you showed seemed to be from that was a satellite that's more than 20 years old, right? It was put up several decades ago. Kind of paint a picture for me and for the audience of what that new image will look like from this instrument.
Very similar to what I showed was from the ESA NASA SOHO satellite, which was launched in 1995, well beyond its design life, and we project that it's going to not be able to sustain operations because of decay in the solar arrays sometime in 2026, and the image that we're going to get from the C-Core 1 is going to look a lot like that it's going to have imaging imaged the the corona from about 3.7 solar radii out to about 17 solar radii. So that was pretty much the blue area you saw in that video there. And so that we learned a lot from this research satellite, and that helped us to optimize and design the observations we needed for the GOES-U coronagraph. And it's going to hopefully look a lot like that, better resolution. And what's very key is much faster latency. We're going to get the data down much faster to the Space Weather Prediction Center so they can use it in their operations. Right now, SOHO LASCO data can have gaps up to 8 hours before we get the data down. So a lot can happen then, and then having this new capability will certainly build resilience to space weather for us.
An eclipse every 30 minutes, right?
Every 30 minutes from when we see the when we image the corona down to the forecasters.
Here in the U.S., we have to wait 20, 30 years before we can see it. We just had one across the U.S., and we've got one coming to Florida, but we got to wait a while. All right, we've got another question online, another hashtag Ask NASA question. Put them in if you have one that you want answered with our experts today. 2 questions, and it's back to Dr. Talaat. Number 1, will the coronagraph work 24/7, or won't it be a night at times and thus unable to observe the sun? And then the second part of the question, I'll let you answer that first, and then I'll hit you with a second.
So the position in geostationary orbit allows us to see the sun pretty much 24/7. There's a few times when there's obstructions because the moon may obstruct the view, some occultations there, but pretty much we will have observations of the sun 24/7. And that's also why we have solar imaging on both the east and west, so that when the Earth or the moon obstructs the view, we have the other satellite that will provide the imaging of the sun that we need in the forecasting, for forecasting, et cetera. So with the coronagraph, the CCOR 1 is, of course, the first one and this is the last of the GOES satellites. So we're going to fly the CCOR in geostationary orbit. But as I mentioned at the beginning, we're going to also fly a compact coronagraph on the SWIFL L1 satellite. That's 1 million miles upstream of Earth. That acts as an upstream buoy measuring the solar wind and the solar conditions coming towards us. But it is also going to give us a 24/7 unobstructed view of the sun with a CCOR 2, the second coronagraph. And those two, having those two coronagraphs flying will give us resiliency in our system going forward.
So, and she follows up, this is Lucy Alberg coming to us on hashtag Ask NASA. If there's a coronal mass ejection, is it possible to not see one based on that limited time where it's blocked?
On those few instances where we have occultations, we can look at other indications of solar activity. But yes, it would be possible that for that time we would not see the coronal mass ejection. But we also know from the context imager, the SUVI, that they're just like we watch the Atlantic Basin for tropical cyclone formation, we watch the sun for possible impending solar activity. We watch the sunspots and see how they're forming, and from our historical analysis, we can tell if there's a likelihood of eruption. And so we have the other measurements on the GOES West satellite will be able to tell us if there was a large eruption going on.
The forecasting component is certainly very interesting. And she just followed up with one more part, and that is, why do we need coronagraphs in space versus just on Earth?
We can't see the outer atmosphere of the sun, the corona, from Earth very well unless there's a total solar eclipse. And so that's why we have to fly it in space and do the occultation up there to see it in a 24/7 capability. You can see it from the ground through ground telescopes, but that's susceptible, of course, to cloudiness and the location as the Earth rotates around. You can't observe it from a chronograph at night, for instance. So having it in space gives us the constant, continuous observations that we need to measure it for operations.
All right, very good. Now, we can't finish without getting a few words from Chris Wood and having him take a few questions, which I'm just curious, Chris, what is it like to fly a plane through 150-mile-per-hour hurricane winds?
So every pass in every hurricane is unique. The most common analogy we like to use is think about going on an old wooden roller coaster while being simultaneously in a car wash. So there's a lot of rain, there's a lot of wind, there's a lot of bouncing, but sometimes it can be as benign as kind of going down an old dirt road, just bouncing around a little bit. And then sometimes it's one of the wildest rides you've been on in a long time.
And in that video, I've seen a clip of some video. I mean, this is turbulence like no other, right? We all experience turbulence when we fly, but you've got like, you're at the apex of turbulence. Are you weightless for moments when there are some drops that just absolutely let you go?
Yeah, so there's definitely some occasions where you're going to be a little bit on the weightless side. For most storms, that's not going to be the case. You're going to get some bounces. We're going to move a couple 100 feet in the air column as we're going through the eye walls. But in general, you're not completely weightless. You might lose a few pounds as you're going through some of these bumps, but you're definitely not going completely weightless. However, on occasion, that will happen. I'm thinking specifically of when we were flying through Hurricane Ian. We definitely had a couple moments where you were really thankful you had your seatbelt on.
I won't ask how you lost those pounds. Last question. When you get into the eye, is it total calm? Is it easy, breezy flying?
So the eye has a point where it does come down to total calm, but there generally is a distributed wind field throughout the eye of the hurricane itself. So it doesn't immediately calm down. You can't just break out of the clouds and then just kind of like drop everything you're doing. You still have to be engaged in what you're doing because you could still have, even on the other side of the cloud wall, 100-mile-per-hour winds at flight level.
Thank you very much, Chris, and thank you to all of our panelists. We appreciate you being here and sharing your knowledge and information. That's going to wrap up our briefing for today. A couple of programming notes. We have a pre-launch briefing with the latest on launch readiness for GOES-U. That's scheduled for 5 p.m. Eastern Time right here on NASA TV. Also, if you'd like to join the conversation online about this important weather mission, post your social media comments or questions with the hashtag #ReadyToGoes. Ready to Goes. And a reminder, our launch is at 5:16 p.m. Eastern Time, and NASA Television will cover it starting at 4:15 p.m. Eastern Time. Thank you for all joining us. We appreciate it. Have a great day, and go NASA, go NOAA, and go GOES-U.